So we're going to continue factoring and talking about what the strategies may be. So on the first one here, G, there are two terms, 48 and 3 can both be divided by 3, so we're going to start there. We're going to factor out a 3 as well as x squared is the smallest coefficient of x, both are shared, and y. Okay, 3 goes into 48 16 times. Okay, so it's going to leave us with 16 times x squared. Take on off the y already, so that's gone. Minus, I've already divided the 3 out, the x squared out, and the y out, so I'm left with 1. Alright, so we've taken out a coefficient of 3x squared y. That was the greatest common factor. Now the 16x squared minus 1 has two terms, there's still a square. It can still be factored. This is a difference of squares, and it is because 16 is 4 squared. So let's factor it one more time using the difference of squares. So factor into 4x plus 1 and its conjugate 4x minus 1. Now that's completely factored. I can't break it down further because I don't have squares in my x's anymore. And there's nothing in common between the 4 and the 1. Okay. In letter H, when I look at this one, I notice that there is no greatest common factor. There's no number that I can divide into all 3 pieces. Then I notice that there are 3 pieces and the coefficient is 1. Since the coefficient is 1, I'm going to grab that negative 48 and begin there. It's negative, so I'm going to have a positive and a negative. I want the larger one to be the negative. So let's think about what goes into 48. 48 is 8 times 6. So 8 times 6. I wanted the large one to be negative, and I did this wrong on accident. I did 8 minus 6, which is 2. So let's just switch that up real quick. I needed the larger one to be negative, the smaller one to be positive, because I want that 2 to turn out negative. Alright, so since my coefficient is 1, I can just put these right in the parentheses. This is going to factor into x minus 8 times x plus 6. And again, that's because I already know that the only way to get x squared is with an x times an x. Then I've got my 6x minus 8x is negative 2x, and my negative 48. Okay, letter I. 3 terms. I can divide those all by 5. And they don't have anything else in common. There's no letter that's in common, so just the 5. Okay, 5 goes into 90. How many times? Let's grab a calculator real quick to make sure we get this right. 90 divided by 5 is 18. So 18x squared plus 3xyz minus 50 divided by 5 is 10. Y squared z squared. Okay, so far we've factored out the 5. I still have a trinomial, but now this trinomial has no number that can be divided into all 3 and no common letters that can be taken out. So it needs to be factored some more. There is a coefficient here, so I can't just use the last number. I can either use trial and error or I can use grouping. I'm going to go ahead and try grouping with this one. So I'm going to multiply first and last. 18 times 10 is 180. That'll be negative because the 10 was negative. Let's try to find 2 numbers that go into 180. It'll have to be one positive, one negative, and I want the positive one to be larger. So 180 is 18 times 10. So if I start there, 18 minus 10 is 8. Okay, so that's not going to work. I need to get a 3. So let's go larger than 18. Okay, so maybe 20. 180 divided by 20 is 9. 20 minus 9 is 11. So I went the wrong way. See, I'm getting further from 3. So instead of larger than 18, let's go smaller than 18. So 180 divided by 16. Oops, I forgot to hit the divided key. That didn't work. So let's try again. 180 divided by 15 is 12. So 15 minus 12 is 3. Okay, so when I split this up for grouping, I'm going to split it up as 18x squared plus 15 xyz minus 12 xyz minus 10 y squared z squared. Okay, so when I group the first two, 18 and 15 have 3 in common. They both also have an x, so it'll be 3x times 6x plus 5yz minus 12 and 10 have 2 in common. They both also have at least one y and one z. Okay, so 12 divided by 2 is 6x. The y and z are taken out. Negative 2 into negative 10 is positive 5. There's still one y and one z left. So this has a 6x plus 5yz in common. They both have that parenthesis. I'm going to take that out. I'm left with 3x minus a 2yz. And I don't want to forget that I originally factored out a 5, so I'm going to go back and throw that 5 in the front here. So this is my final answer. Okay. Alright, and the next one, two terms, 80 and 45, they can both be divided by something. Or can they? Yes, they can both be divided by at least 5. So let's take a 5 out. If I divide them by 5, I'm going to get 16 x squared minus 9. Okay, two terms left, no number in common, but they are both perfect squares. I have a difference of squares here. It's going to be 5 times 4 squared is 16, so I'm going to have 4x, and 3 squared is 9, so 4x plus 3, and its conjugate, 4x minus 3. So that's going to be my final answer on this one. And we've got 2 more practice problems here. Let's make sure I can read this. Okay. So my practice problem is 2bx squared plus 44bx plus 24b. I'll divide them all by 2 and by b. So let's take 2b out of everything. That's going to leave us with x squared plus 22x plus 12. Right? This is a trinomial. The coefficient is 1, so I can factor it by looking at this 12 right here. It's positive. It needs to add to a positive, so I'm going to have 2 positives. Okay, what goes into 12? We have 2 and 6. 2 and 6 add to 8. We have 3 and 4, which add to 7, and 1 and 12, which add to 13. So with 12 being my last number here, I don't have a way of adding up to something as big as 22. So that means that this right here cannot be factored further, and I want to leave this work right here to show that I've thought of all the possible ways of multiplying to 12 and that none of them worked. So this right here has been factored a little bit. That was as much as I could do. So the remaining portion was prime, but it was factored some by taking that 2b out, so the answer is not prime. Okay, and our last one. It's a trinomial again. They can all be divided by 3, and they all have at least an x and at least a y. Okay, so when I take that out, I'm left with 2 over 4. Take 1 out, so x squared is left, or cubed. Cubed is left. I had 4 and I took 1 out, so I've got 3 left. Plus 4. There were 3, took 1 out, so there's 2 left. 4x squared minus 3. Okay? Now, this can't be factored any further because even though it's a trinomial, it doesn't fit my right pattern. It's not x squared, x, no x. So this is not something I can continue to factor because of the cube that's left over there. So this is done.